Today, we're going to take a break from the turbo diesel Honda project, and the reason is, well, we may have actually found a better option for the turbo, and before we continue screwing more parts onto the car, we want to have a better look at the alternative turbo. And just to give you folks a bit of a hint, we found a bolt-on turbo that's made for the Kubota engine, so it may be worth the wait. The good news is, the new turbo is on its way and should arrive soon, and when it does, we'll pick right back up on this project next week. So in the meantime, well, today let's go ahead and play around with the 420cc Predator engine and install a completely automatic choke. Now over on the table, we have two electrical options and a completely mechanical solution. And I'll get into the details of both systems, plus later on in the video, we're going to build a gadget that will allow us to remotely control the throttle on this 420cc engine. So, if you like the gadgets, gizmos, or the nuts and bolts, we got you covered one way or the other. Alright, let's get started. So getting the 420 Predator engine started is relatively simple, and all that's required is just to flip the choke on the carburetor and give the recoil one or two pulls. Now, we're lucky and this engine also has the electric starter option, so we can just turn the key and the engine will start right up. Well, at least it should. So for some reason, it seems the choke needs to be set every time you start this engine, even when the engine's hot. And that's when it becomes annoying to hit the choke every time, especially if the engine's mounted in a remote location. In an ideal situation, this ignition switch could be mounted where it would be more convenient to use, but since we have to manually flip the choke on, it sort of defeats the purpose of having a remote ignition switch when you have to manually set the choke. So the solution is to fit the engine with a completely automatic choke, and that way we don't need to keep fiddling with the choke every time we want to start the engine. So this thing is an automotive door lock actuator, and it has a little electric motor inside of it that'll drive this rod in and out depending on the polarity of the voltage that we feed it. Now theoretically, we could gin up some mounts, brackets, and whatnot to attach this thing to the choke lever on the carburetor, and a lot of people have apparently done this with great success, but it takes a lot of work to do this to get everything just right. So we're not going to be fooling with this thing. You know, this may be the cheapest option, but at the same time, it's also the hardest to get to work. Let me take this thing over to the bench and I'll show you something else that you need to be aware of if you want to fool with these low-cost actuators. So these things were designed to lock and unlock car doors, and they can tolerate a brief pulse of power. But if you leave them energized for too long for whatever reason, it'll trip an internal fuse. Now some of these have automatic resettable fuses and some do not. So what that means is when the fuse trips on some of these gizmos, that's it for the actuator and it's now bricked. So if we apply power to this guy and leave the power on, it'll either trip the resettable fuse, or if it doesn't have a resettable fuse, it'll blow the internal fuse, and that ain't good. And after about 30 seconds, well, this thing is dead. Now I'm not sure if this thing needs to cool off to reset the circuit breaker, or it's blown an internal fuse. So let's let this thing sit for about 10 minutes and then check it again. Alright, it's been about a half hour, and let's see if this thing has reset itself. And nope, it's dead. Well, that sucks. Now keep in mind, this is a cheapo aftermarket gizmo, and apparently it doesn't have a resettable fuse. Now there's absolutely no reason to leave the power on for as long as I did, but just in case this gizmo gave you ideas on perhaps using it for a different application, you need to be aware of the fact that it may self-destruct if you keep it energized too long. Alright, next we have this miniature linear actuator, and some places do sell these things to be used for automatic chokes. Now this guy was $30 on the Jungle site, and I've seen these things sell for up to $100 elsewhere. The good thing about these things is they have internal limit switches, and these will not burn out if you leave the power on in either direction. Actually, to use these things properly, you need to get a forward-reverse module for an additional $20, and at that point, it's still not completely automatic, and you would have to press a button to get it to work. Now this one has a 2-inch stroke, and that's way too much for this application, but there are others that are available with a much shorter stroke. Anyway, this ain't gonna work out without a huge amount of effort, but if you don't mind the effort, apparently these things can be made to work. So that leaves us with really one option for a completely automatic choke, and that is to use an automatic choke that was made for the Honda GX390 engine that's used on the generators. These gizmos can be had for about $15, which is really nice, but unfortunately they won't work on a Predator carburetor, so you'll also have to get a Honda GX390 carburetor that was made for a generator. You see, the generator carburetors have the special interface for the choke that allows this automatic choke gizmo to work. Now, a GX390 clone carburetor for a generator runs between 15 and 30 bucks. Plus, you're also going to need a carburetor spacer that has a vacuum port. Now, these things can be had for not a lot of money, and they're used for the automatic chokes and for powering pulse-type fuel pumps. Anyway, we'll use this thing as a vacuum source, and that'll get the diaphragm in the gizmo to pull the choke open when the engine starts. Now, the good news is all this stuff is really inexpensive if you shop around, and the GX390 carburetor uses the same jets as the Predator carburetor. So what that means is, if you want to tune the GX390 carburetor, well, you can use the abundant selection of Predator jets that are available. Anyway, we ended up using a number 41 jet in this carburetor to get a slightly richer mixture. But to be fair, the jet that was supplied with the carburetor was definitely usable. Now, the Predator air filter assembly is just not going to work no matter what you do, and probably the best alternative is to use a commonly available large air filter kit. And once again, if you shop around, you can get these big air filter kits for cheap. Alright, let's put this stuff on the engine and see if it'll work the way we want it to. Well, I reckon we need to take this guy apart first. Now, this is the stock Predator carburetor, and the choke interface thingy is completely different than the one that's used on the Honda GX390 carburetor that's meant to be used on generator applications. As you can see, the GX390 carburetor interface thingy is a lot bigger, and there's just no way the automatic choke gizmo is going to work on the Predator carburetor. Oh, I almost forgot. Now, the GX390 carburetor has this anti-backfire solenoid on it. Now, when this solenoid is energized, it'll cut the fuel to the engine and prevent backfires when the engine's turned off. So, on a big engine like this, when you shut the ignition off, well, it takes a while for the engine to stop rotating. Anyway, during the few seconds the engine's still rotating after the ignition is shut off, the carburetor is still feeding raw gasoline into the engine, and it gets pumped into the hot muffler. Now, this will potentially cause a backfire a few moments after the engine's shut off. This anti-backfire solenoid, it'll stop the carburetor from feeding raw gasoline into the engine and thus preventing a backfire. Now, on this carburetor, the way the solenoid works is completely backwards from the way most engines are set up, and this solenoid needs to be energized in order to prevent the backfire. So what that means is, it doesn't need to be hooked up on our application. Actually, if you did hook it up and send 12 volts to it, the engine would never start. Like I said, this one is backwards from the way most manufacturers do it, so the bottom line is, don't connect these wires to anything and you'll be fine. This engine didn't have an anti-backfire solenoid originally, and we certainly don't need one now. Alright, let's continue with the disassembly. And now we can install the new carburetor. This new manifold spacer will go on first. Now, there's already a gasket on the engine, and it looks to be in good condition. Of course, we also have a gasket on this side of the spacer. And next comes the carburetor. Now, this carburetor has an idle mixture adjustment screw on it, which is nice. Now, you'll find that most aftermarket carburetors do have an idle mixture adjustment, whereas the original carburetor didn't. The dirty little secret is, most OEM carburetors do in fact have an adjustment, but it's hidden under an anti-tamper Welch plug on the carburetor. You know, this is an EPA thing, and the EPA feels the consumer should not have access to any of the adjustments on the carburetor. Now, I definitely know a few people that can screw up anything, and for those folks, perhaps an anti-tamper carburetors are the best. But if you know what you're doing, well, it's nice to have access to the idle mixture adjustment. Anyway, the GX390 carburetor connects to the governor linkage exactly like the original Predator carburetor. To install the linkages, the carburetor needs to be about an inch away from the intake manifold port in order for the linkages to slip into place. Once the linkages are in place, then the carburetor can slide all the way on. Next, we pop in a gasket, and then we can install the automatic choke gizmo. Now, this little rod had to be trimmed about 3/16 of an inch, and the reason is, this rod will come in contact with the aftermarket air filter when everything's installed. So this is actually the tricky part. The linkage on the automatic choke can be installed two different ways, and if it's installed correctly, the choke plate will be in the closed position. Now, if it's not installed correctly, the choke's going to be in the wide open position, and it'll never work. This is something to be aware of if you're actually doing an upgrade like this. And now we can install the aftermarket air filter adapter. So on this close-up, you can see how close the linkage gets to the air filter adapter, and I had to trim the linkage about 3/16 of an inch to gain enough clearance. So this choke conversion was done with cheap aftermarket parts and not genuine Honda parts. When you go down the path of using cheap parts, sometimes not everything's going to fit perfectly, and a little bit of fiddling is required. I think it would be completely unreasonable if you expect cheap junk to work perfectly. And if you want perfection, consider using genuine Honda parts. And now we can install the vacuum hose from the carburetor spacer to the diaphragm on the automatic choke. So this is just a heads up. Directly connecting the vacuum hose will work, but there is a better option. So before I get into that, let me get the engine started and I'll show you something that's a bit alarming. Alright, let's fire this thing up. And the automatic choke worked perfectly, but now you can see the choke plate is having fits, and that's because at idle the vacuum on a single cylinder engine pulses. This would probably work, but it may cause the diaphragm or the linkages to wear out prematurely. So we're going to install a restrictor in the vacuum line to even out the pulses. Now this little guy is a two-way restrictor valve from an aquarium. They also make one-way restrictor valves with a check valve, and those won't work in this situation. We need a two-way valve. You see, the check valve version will not allow the vacuum to bleed off when the engine's shut off, and the automatic choke won't function the next time you try to start the engine. Alright, let me install this two-way restrictor while the engine's still running. That pretty much fixed our problem. Now this restrictor is adjustable, and by turning this knob you can adjust the amount of restriction you want, and you want to adjust it so the linkages stop fluttering, but no more than that. Alright, let's turn the engine off and see if the choke resets. Perfect! That's exactly what we want. Now let's start the engine again. Yep, that works perfectly. Now, I'm not sure how the original Honda Gizmo is supposed to work, but we got this random collection of cheap parts to work just as good as Honda quality, possibly a little bit better. And now we can install the air filter. Now, this filter needs a hose clamp to stay in place, but for now it'll work. Now here's something I forgot to mention earlier. The throttle arm had to be bent up just a little bit to provide enough clearance for the throttle to get full range, but that was a simple thing to do. So at this point, we can move the ignition switch to a more convenient location, and I'll never have to fiddle with the choke again, and that was the whole reason for this upgrade. And now it's time for building gizmos and gadgets with Jimbo. Today's project is throttle servo. Now, this thing over here is an RC servo-based contraption that can pull a throttle cable, and we're going to use this to control the throttle on the 420cc Predator engine. Today, our main focus is going to be on this thing. However, I will explain what this stuff is over here. Now, the reason I need this gizmo is because the throttle on the engine will eventually be controlled by a microcomputer, and we need a way to interface the computer with the throttle. What I'm going to be showing you today is an interesting and low-cost way to build a cable pull servo that can be used with or without a computer. So these are most of the parts that we're going to be needing, and aside from the 3D printed parts, all this junk can be picked up from the jungle site. So the servo that we're going to be using is this heavy-duty Metal Gear unit, and we're going to get it to pull on this bicycle shifter cable. Now, keep in mind, shifter cables for bicycles are thinner and more flexible than brake cables, and on this application we want the cable to be very flexible. And this over here is regular bicycle cable sheathing. I believe this is for the brakes, and the inside diameter is a bit oversized, which will reduce the friction on the cable when it passes through it. Now this heavy-duty servo operates at 6.8 volts, and we're going to need a way to feed this thing the correct voltage. And to do that, we're going to use this low-cost adjustable buck power converter. This guy will take the 12 volts that we do have and reduce it down to 6.8 volts. Now, one of the things I like about this thingy is it's in a really nice package, and you can just bolt it and wire it in place and not have to screw around with anything. Now, speaking about screws, on the back side of this guy, there's an adjustment screw so you can adjust the voltage, which is very convenient. So, no worries, this buck converter will supply plenty of power for our servo. Now to control the servo, we're going to be using this cheapo servo testing circuit board. Now this thing is actually for testing servos, and it's more of a tool than anything else, and as I recall, it was about 12 bucks. Anyway, it has a standard servo plug built into it right here. Now this is a cool gadget all by itself, and today we're going to be using it. However, eventually we'll be replacing it with an Arduino Uno, but we're not ready for the Arduino yet. So using the servo test circuit board is a quick and easy way to control the servo while we build the throttle cable pulling gizmo. Over here we have a 3D printed part that I designed with Tinkercad. Now Tinkercad, well, it's a free cloud-based utility that provides a simplified version of a CAD program for folks who don't really know how to use CAD programs, like me. And these two thingies, they're also 3D printed parts, and they're made from ABS plastic. Now ABS plastic is perfect for an application like this, and it can handle the elevated temperatures that this part may be seeing. So a lot of people have asked me this before, and the 3D printer that I use is a Prusa Mark III. It's been a great printer, and I haven't had any problems with it in the last 2 years. Anyway, this servo horn fits the plastic parts like this, and this is what we're going to use to interface the 3D plastic parts with the servo. These horns are extremely cheap, and you can get about a half dozen for a few bucks. Now for the servo mounts, we're going to be using these aluminum spacers, and they'll provide us with an easy way to mount the servo inside the enclosure. These aluminum spacers measure in at 30 millimeters long, and I believe they have a 3 millimeter internal thread. Now, metric fasteners are not cheap or easy to get here in the States, and I buy the fasteners in these bulk packages. This is definitely an inexpensive way to get the little screws and nuts for my 3D printed projects. So for the enclosure, well, we're going to be using this heavy-duty ABS project box. Now, this is something I've already had in stock, and it seems to be the perfect size for this project. Now, before we get started, I want to go ahead and power up this buck converter and confirm that it's set to the proper voltage. Now, this little guy is a 12-volt battery that I keep around for a quick source of power for my projects. And I'll just connect the black wire and the red wire to the battery, and we can power up the buck converter. Alright, well, according to the Fluke, we have 6.7 volts, and that's close enough. Now, if I did need to adjust the voltage up or down on this thing, I can do that by turning the adjustment screw on the back side of this converter. So far, so good. Let's go ahead and plug the converter into the servo test board so we can confirm that the servo works as expected. Awesome! This servo is a working unit. Now around here, you never know what works or not. And the good news is, well, we found a working servo today. Okay, so we're definitely going in the right direction. Let's go ahead and build out this throttle cable pulling gizmo. So off camera, I went ahead and marked out and drilled the holes in the enclosure so we can mount the servo. Basically, I just centered the servo in the enclosure and dropped it about 16 millimeters from the top edge. It's pretty much just random numbers, but it should be just about what we need. So now I need to install aluminum spacers onto the servo. Fast forward a few minutes and the spacers have been installed. Next we have to mount the servo inside the enclosure. And the servo's mounted. Alright, now we need to put together the pulley thingy that attaches to the servo. The cable will fit into this side, and now I can install the other half that'll hold this cable in place. Now it may be hard to see these parts on your mobile phone, so this is a snapshot of the CAD drawing. So when these two parts are put together, this raised area provides the space for the cable to wind up inside the pulley. It's as simple as it gets. Fast forward a few minutes, and the pulley is assembled, and now we can mount it to the servo. So I ended up having to drill a hole into the side of the enclosure in order to get an Allen wrench to tighten the center screw on the servo. Otherwise, it would have taken an hour to get this screw all the way in. Now on the front side of the enclosure, I went ahead and pre-drilled the holes that we're going to need. For the cable guide, we're going to be using this aluminum cable thingy from a generic motorcycle brake handle. You can get a bunch of these in bulk for a few bucks, and I always have a few in stock. Alright, the cable has been fed through the cable guide and everything seems to fit okay. This gizmo would be fine just the way it is. However, I went ahead and 3D printed another part so I can firmly attach the cable to the enclosure. And there we go, the part's installed. And now we can slide the cable sheath into position. This little plastic part that I printed may or may not be necessary, but it certainly helps hold everything together. I think at this point, I can install the wires that will connect the servo to the controller board. So I've been building gadgets like this for years, and perhaps I make stuff like this look simple, and theoretically it is. However, without a 3D printer, making stuff like this still can be done, but it takes a lot more effort, and I'm blessed to have a decent 3D printer. Also, after making so many gizmos and whatchamacallits over the years, I've learned exactly what will work and what will fail, and the next time I build something, I always try to build it a little bit better. You know, I think this thing should hold up just fine for what we're going to be using it for. Alright, let's power it up. That's perfect. Now keep in mind there's no tension on the cable yet, so it's a bit jumpy. However, once we connect the cable to the throttle on the engine, the tension will make it a lot smoother. Now ultimately, we're going to be using a microcomputer to send the commands to the servo, but as you can see, the low-cost servo test board is an excellent alternative to the microcomputer if you wanted to build something like this and don't need a computer to operate it. Now, I'm absolutely not affiliated with the Jungle site in any way whatsoever, but I've come to realize that I should eventually become an affiliate, and that way I can provide the proper links for the parts that I used, plus I'll make a few bucks.
I like money though.
But the last thing I want to do is take advantage of the good folks who watch this channel. So it's a bit of a dilemma for me, especially since most of the stuff on the Jungle site is just pure junk. Anyway, a project like this is supposed to give the viewers ideas, and perhaps they can see an application where something like this would work in a project they're working on. Now, I depended heavily on the 3D printer, but if I didn't have a 3D printer, well, I would have whittled the pulley parts out of FR4 fiberglass sheets. FR4 is cheap and it's robust, and it's exactly what I used to use before I got the 3D printer. Alright, let's connect this gizmo to the throttle on the engine and test it. Fast forward a few minutes and the servo's connected to the throttle. Let's fire this thing up and see if it works. Not too shabby. We have excellent control of the throttle, and I can raise and lower the engine speed with precision. That's exactly what I wanted. You know, this'll all make sense in a future video, but I'm sure a lot of folks know where this is going. Now, just for fun, I tried out a 20-foot extension of the control wiring, and the throttle still works fine. Now, this is a bit extreme, but the good news is, now I know that the gizmo will work on a super long extension. And if you're curious, the extension wiring is 22 gauge. Well, if you made it this far in the video, thanks for hanging out with me today. Hopefully, we satisfied the nuts and bolts people and the people who like the electronics. I reckon I have to get working on the turbo diesel Honda, so I'll see you next time. Until then.